So hello everyone, today we will be discussing about the topic of PMDC or permanent magnet DC and shunt and series DC motor. Let's start with the first slide, DC motor construction parts. This slide features a label diagram illustrating the key components of a DC motor, focusing on PMDC, shunt and series type. It highlights the basic structure and assembly. Shaft, the rotating part that delivers mechanical power output from the motor. Armature, the rotating coil or core where current flows interacting with the magnetic field to produce torque, shown in pink. Armature conductors, wire on the armature that carry current and generate the magnetic field. Commutator, a segmented copper ring on the armature shaft that reverses current direction in the armature windings to maintain rotation. Brushes, sliding contacts that supply current to the commutator from the external power source. Field windings, coils around the poles that create the stationary magnetic field. And pole shoe or frame, magnetic poles, NNS north or south, mounted on the frame, shaping and directing the magnetic flux. Interpoles, small auxiliary poles that place between main poles and compensate for armature reaction and improve commutation. Yoke and frame, the outer iron structure that provides a path for magnetic flux and houses the components. So the diagram shows a cross-section view with NS poles, emphasizing the interaction between a stationary and rotating parts for torque generation. So for the next slide is introduction to DC motors. The introductory slide defines the DC motor and classifies the main types covered: PMDC, shunt, and series, excluding compound motors. So by the way, what is the DC motor? A machine that converts DC electrical energy into the mechanical energy through electromagnetic interactions. So to the classification overview, PMDC on field excitations using permanent magnets, ceramic or neodymium for the field instead of the windings, simplifying construction. Self-DC motors, it is the field that creates the electromagnetic windings. DC shunt motor, field winding connected in parallel with the armature. DC series motor, field winding connected in series with the armature. Compound motor combines shunt and series characteristics for balanced performance. So the key insights, let's and for the third slide, the permanent magnet DC or PMDC motor. Construction and characteristics: uses permanent magnets on the stator instead of the field windings, reducing complexity and eliminating field copper losses. And operation: when DC voltage is applied to the armature, torque is produced due to the interaction between armature current and the field magnetic flux from the magnets. The advantage: no field current losses, simpler, smaller, and lighter construction for the same power rating compared to the wound field motors. So disadvantage: speed regulation is poor, speed is inversely proportional to flux, but since flux is fixed, speed control is limited and can become dangerously high at no load conditions. Difficult to achieve a starting torque without additional mechanism. And for the fourth slide is the DC series motor. This slide is explain the series connection in DC motors, emphasizing high torque capabilities and speed behavior under load. Connection and high torque. The field winding is connected in series with the armature, so the same current flows through both. Field winding made of low resistance wire to handle high currents, producing strong flux proportional to armature current. Speed regulation: poor speed is inversely proportional to flux at no load, and flux is very small, making speed dangerously. Under load, speed drops significantly. Starting torque: very high and constant, as torque is proportional to the square of the current. Speed control can be controlled by varying armature voltage or using series resistance. Applications: electric traction hoists and cranes where high starting torque is required. For the fifth slide, DC shunt motor. This slide covers the parallel connection in shunt motors. So connection and constant speed. The field winding is connected in parallel the armature terminals, so field current is constant and independent of load. Field winding made of high resistance wire to limit current. The field produces high, nearly constant flux speed regulation. Good speed drops slightly with load but remains fairly constant to use stable flux. Starting torque, medium lower than series but adequate for many applications. Speed control can be controlled by varying the armature voltage or by varying field, adding resistance to weaken flux and increase speed. So next is application. Latches, centrifugal pumps, fans and blowers where constant speed is required. Key insight provide stable operation under varying load, making it suitable for precision machinery. To starting current can be high without additional controls. Comparative summary of DC motor types. Starting torque, PMDC. Good permanent magnet provides consistent flux. Series, very high, proportional to current squared. Shunt, medium, constant flux limits peak torque. Speed regulation, PMDC good, fixed flux stable. Series, poor. Shunt, excellent. For the speed control, armature voltage. Series, difficult. Shunt is armature voltage or field control. And for the best for is PMDC, low power uses and portable low weight applications. And for series, high starting torque and fluctuating loads. Shunt, constant speed application. And so for the last topic, last slide, application in industry. This slide outlines the practical and the industrial uses for each DC motor type, linking characteristics to the real-world scenarios. So PMDC motors is a robotics where small actuators and joints requiring complex lightweighting designs, automotive, windshield wipers, and power seats. HVAC blowers for efficient low maintenance operation, computer peripherals, disc drivers, cooling fans. So in DC series motors, cranes and hose needs to lift heavy loads from standstill. Electric traction, trains, subways, cars, and electric vehicles. And for the DC shunt motor, machine tools, latches, drilling machines, and milling machines where speed stability is crucial. Pump and compressor, centrifugal pumps where constant speed ensures reliable flow. So that's all for my discussion about this topic, PMDC, shunt, and series DC motor. Thank you.